properties of acids. Acids have a sour taste. They will dissolve many but not all metals. And they will turn blue litmus paper red. It can be a little hard to see what we're exactly looking at here. This is the original color of the paper. Some of them are, this looks more lavender to me. This is a watch glass with some acid. When we put the blue litmus paper into the acid, the litmus paper turns pink. Or they say it's red, it looks pink. Litmus is a chemical that is sensitive to hydrogen ions, and so it'll turn pink or blue, depending. These are some examples of acids. We've heard of these because we learned how to name them. Here are uses for them. They're used a lot in cleaning, manufacturing. You need them in fertilizers and different things. Hydrochloric acid is the main acid in your stomach acid. If you've ever, had the flu and thrown up, there's that nasty sour taste, right? That's because there's hydrochloric acid in your stomach. These are structures and space-filling models of several of these acids. And what we notice here is they all have this hydrogen ion that can come off. And that's the acidic hydrogen ion. When you put an acid in water, it ionizes and releases a hydrogen ion. Properties of bases. I'm going to run these two sections together. Bases taste bitter. Acids are sour, bases are bitter. Bases have a slippery feel because they actually begin to make soap with the oils on your skin. And if they remain in contact with your skin, they'll actually dissolve your skin. And bases turn red litmus paper blue. The way I remember that is bases turn it blue. They both start with B, right? So here's a red litmus paper. We stick it in this watch glass containing a base, and the paper turns blue. We do not eat many things that are basic. These are common consumer products that contain bases, and most of those are not good for you. Tonic water isn't going to hurt you, although I don't see why you would want to drink that. Here's Maalox and antacid, but the rest of these things are definitely something you don't want to be consuming. So bases are much less common in foods. Alkaloids, that's a group of organic bases that are found in plants. Have you heard of hemlock? Should you eat hemlock? No. I think Shakespeare used hemlock in several of his plays. Hemlock is poisonous. The bitter taste of bases serves as a warning to us, hey, don't eat this, it's not good for you. There are things that have a bitter taste that aren't going to kill you. Coffee. Coffee is actually overall acidic, but caffeine, which is, the best part of coffee, is a base and does have a little bit of a bitter flavor. That's why I personally can tell the difference between Diet Coke and caffeine-free Diet Coke, right? Because the caffeine-free soda doesn't have that bite. It's that bite, that little bit of a bitter taste that makes you go, when you drink it. Just my own little personal issue here. This is one of my favorite molecules, caffeine. So examples, properties of bases. It's not really properties, it's uses. Sodium hydroxide, potassium hydroxide, sodium bicarbonate. This is baking soda. But it can be used as an antacid, a source of carbon dioxide. When you add baking soda to something that you are going to bake, like cookies or bread or quick bread or something, the reason that you're doing it is because it will react with any acid that's in the recipe and form carbon dioxide bubbles, and that will help your baked goods be fluffy. Ammonia is often used as a detergent. I'm not.
For, we prep a slide for a swab.
Okay.
Looking for use, I think, is what the KOH and the wet mount for the lab.
Mm-hmm.
What is it reacting to?
So Yeah, the student's saying that they use potassium hydroxide in a wet mount for a test for yeast. Bases are used for lots of different things. It could just be adjusting the pH, but what bases do when they come in contact with things like protein is they denature the protein. And so they'll deactivate enzymes, they'll do all sorts of things.
Does that make them more easily visible in their microscope?
It could make them more visible, yes. It will alter their properties, may cause them to react better with a stain. There's a lot of different possibilities there, yeah. But, you know, things like potassium hydroxide and sodium hydroxide are in a lot of things. And in small quantities, they're not going to kill you. But large quantities will dissolve your skin. So here's just a little life hack. I'm sure many of you have experienced a problem where the drain, either in the sink or the bathtub, gets really slow because it gets full of hair and it's all nasty and slimy and disgusting, right? The best way to get rid of that, if you don't have a septic system, is to use a drain cleaner that contains sodium hydroxide or potassium hydroxide. You pour that down there and let it sit, and it will dissolve the hair, and then it can flush out and you're good to go. If you use a drain cleaner that has hydrochloric acid or some other acid in it, that'll clean out some kinds of clogs, but it won't do much on hair because hydrochloric acid doesn't dissolve hair very well. So that's a tip. Sometimes it's helpful to be a chemist because you can approach those household problems with a little more of an educated guess to what you're doing.